Welcome back, nerds. We're going to go ahead and finish up the, what was it, 7.2? 7.2 notes? Talking about, the lesson's called Solving Exponential Equations, which is really strange because that's not what we're going to be doing today. Today we're actually going to be talking more real-world mathematics, more money, talking about compound interest. Okay. So here I have a formula for you that you were technically already using. You might not have realized it, but you were using it. Let me show you how. This is actually the formula you were using when we were talking about, actually I should have used the variable a, when we were talking about this. So the other day I had you doing savings account questions like this, and it was like, how long after 20 years and things like that. This is actually a specialized version of this equation. P is still the same thing, principal amount, beginning amount. R is still the same thing, the interest rate written as a decimal, never as a percent. T is still the same thing, time in years. A is still the amount you have. The only thing that's new is the introduction of this N. And, these are both N. What is N, though? N is the number of times per year that your interest is calculated. Okay? So this formula is what you get if you say that your interest is calculated one time per year. So if you put a 1 underneath the R, it's just R, and if you do 1 times T, it's just T. So this formula is actually the specialized version of this formula. Because in all reality, your interest for most things in life, both debt and savings or what's the other thing, investments, you actually get your interest counted or calculated, or the actual vocabulary for this, compounded, multiple times per year. Multiple times. And you might be wondering, well, what's the difference? Why does that matter? Let me hit you with a real-world example that you'll understand. Let's say you start an account, and that account, you start it with $100. And I tell you that you're actually going to earn 100% interest. That means R is 1. Cool with that idea? At the end of the year, you would have $200. Right? Because 1 plus 1 is 2? Great. So if I told you, how about this? Instead of 100% once, how about I do 50% twice? Because 50% twice is still 100%, right? So here's how that would work in all reality. Halfway through the year, I'm going to give you the first 50%. You now have $150. And at the end of the year, I give you your other 50%. Now you have $225. So which one was better? 100% once or 50% twice? Well, clearly, 50% twice was better. Or I could split that 100% into 4 pieces. I could give you 25% 4 times. You'd have even more money. I give you 10% 10 times. You would have even more money. What we're getting at here is the number of compounds we get per year is better as it goes up. The more compounds you can get per year, the more money you will get in a single year. You guys cool with that idea? And you just saw it happen. I could say 100% once, or I could say 50% twice. And the reason, or I could say 25% 4 times. And the reason why the more compounds you have, the better, is because every time the compound is done, you gain interest on your original principal, but then you also gain interest on the interest. So right here, I was getting 50% interest on my principal only. But then here, I was getting that 50% interest on the original principal of $100 and on the $50 of interest I already had. So here we're getting interest on interest, and that's a big deal. And the more times you can get interest on interest, the more money you can get. So if you get interest on your interest on your interest on your interest, hey, we are happy. And that's how real investments work. That's how real savings account work. That's how real debt works. So none of you are 18, so none of you have your own credit cards yet. But you might have access to a parent's credit card, or you might have at least heard that your parents have a credit card. All credit cards, well, I don't know, I can't really give you a real example, but all credit cards have an interest rate associated with them. Let's just say it's an interest rate of about 20%. And that's typically what it is. It's around 20, 23%, 25%, somewhere there like that. It's a remarkably large interest rate. But credit cards and other debt things are going to have, and maybe you've seen these abbreviations on TV, APRs and APYs. They don't really like to advertise this kind of thing when it comes to debt, but they will advertise this kind of thing when it comes to investments or savings accounts. This is annual percentage rate. This is annual percentage yield. This is not in our curriculum. I'm just explaining the difference to you because everybody always wants to know, when am I ever going to use this in my real life? Well, here it is, folks, okay? In that 1 year, your annual percentage rate was 100%. The yield was also 100%. The reason why was because if you took the new and divided by the original, you get 2. So you clearly doubled your money, which is a 100% rate, and it's a 100% yield. But here, at the end of that year with the 2 compounds, you say your rate was still 100% because the 0.5 plus the 0.5 is 1. But if you do the 225 divided by 100, that's 225. That is a 125% yield. So that is the difference between the rate and the yield. Cool beans? Okay. Again, this is not in our curriculum, but I will show it happening in the notes just so you can get a feeling for what it means. Because this idea and this idea I am going to extend further in the next lesson. All right. You deposit $1,700 into a savings account. It pays 1.8% annual interest, but it is compounded quarterly. How many quarters are there in a whole? 4. Okay, good. We want to know how much money we're going to have in our account after 6 years. So what I want to do is I want to fill out all the known letters. What is P, the principal amount? 1,700, yeah, and lots of voices would be great to make sure that I know my entire class is getting it. We've already said it, but what is N, the number of compounds per year? Quarterly? 4. Time is 6. And the rate, remember, you are not allowed to use the percent. So instead of saying 1.8%, what number am I going to put into my formula? Yes, sir? There it is. Remember, we need to move that decimal point to the left twice. 0.018. Sponge boy, me Bob. Money. So I'm going to write in green. The amount of money that we're going to have is 1,700. 1 plus 0.018 all over 4 raised to the 4 times 6. And as long as you're using a scientific calculator that is this one or better, this is very easy to do. If you're using the battery operated calculator, it's not that it's difficult, it's just that you have to think a little bit more. Because for this calculator, all I have to do is type what I see and hit equals. 1700, parentheses, 1 plus 0.018 divided by 4. Close your parentheses. I said close them. There we go. I just missed the parentheses button. This button is exponent, if you don't remember from the other day, so raised to the. Notice that I wrapped my exponent in parentheses. The reason why I did that is because I'm showing you exactly how you need to type it on your calculator. If you don't use parentheses right here, the calculator does not know that that 6 is part of the exponent. If I had just typed this, the calculator interprets that as the exponent is a 4. And after it raises this set of parentheses to the 4th power, it's just going to multiply that answer by 6. The calculator does the order of operations. It's extremely literal. You can't say, well, it knew what I meant. No, you needed to tell it exactly what you meant. And if you wanted a multiplication to occur in the exponent, you had to tell it, do that multiplication in the exponent with a set of parentheses. Now I can hit equals at the bottom right, and I can see that my account has that much money. And since it is money, we will round to 2 decimals, 1893.42. And I'm just reminding you, if this was a real finance class and we were trying to get the actual numbers that a bank would say you have, they would have rounded down to 42 cents as well. But if it was an account that was accruing, which means growing interest, meaning your debt was growing, they would have rounded it up to 43 cents and said you owed them 43 cents. Remember, the banks are always going to give you the middle finger. If it helps you, they'll round it down so it doesn't. They're giving you that middle finger. If it helps them, they round it up regardless of how small the decimal was because it helps them and they give you the middle finger again. Just reminding you that. But since this is a math class and not a finance class, what is she doing back there that she's not looking up? What's going on? She's like braiding hair or something? What is she doing? Yeah. It's exactly what she's doing, isn't she? Unreal. Okay, anyway. And that is going to live in infamy for all eternity on YouTube, just so you know. Anyway, since this is a math class and not a finance class, we will round to 2 decimals. Cool? All right, so the question is finished. We have answered it, but I do want to explain to you the difference between APR and APY because that's real world and everybody always wants to know, why did I learn the quadratic formula, but I didn't learn how to do my taxes? Okay, that's real world. Okay, I'm going to hit you with some real world stuff. You want real world math? Here it is. Your annual interest rate was 1.8%. But let's see what our annual interest, or excuse me, our annual percent yield was. Let's see what the difference is, okay? So we know we were earning 1.8% annual interest. That's our APR. This is the amount of money that's in our account. Let's figure out how much money we earned across the 6 years. So I'm just going to remove the 1,700. Actually, I think that's the harder way to do it. Let's not do it that way. Let's see what percent gain we had. That's the easier way to do it, okay? What we're going to do is we're going to divide by 1,700 to see what our percent gain was. Does that make sense? So divide by 1,700, and I multiply by 100 to see that I now have 111.38% the amount of money that I had back in the day. So over those 6 years, I earned over 11%. Cool with that idea? Great. Allow me to subtract the 100% to say that that means across 6 years, I earned 11 and change percent. Yes? So let's see how much we earned each year on average then? I'll divide by 6. And I will see that on average, each year I earned about 1.896%, even though the annual percent rate was 1.8. The yield, because it was compounding more than 1 times per year, was more than 1.8%. It was almost 1.9%. That's what an APY is, real world mathematics. Okay? What I'm getting at is more compounds equals more money. Cool? Okay. We won't do any more APY stuff. I just wanted you to see it because I want you to understand real world mathematics. Oh, the battery operated calculator. It doesn't understand the order of operations. So if you have the TI-30XA, the one that does not have a nice little solar sensor on top, you have to do the order of operations for it. So you have to do the division. Then you have to do +1 and hit enter. Then you have to say raised to the, you have to type 24. So you need to know what your exponent is ahead of time. Hit enter and then do times 1,700. You have to do the order of operations for that calculator. It won't do it for you. Cool beans? Awesome. Okay. Let's say you deposited money into a savings account 24 years ago. Which letter did I just give you in the formula? T. So what is T? T is 24. Good. The account paid 2.1%. Oh, I guess I know what R is. Remember, move the decimal twice. 0.021. So the account paid 2.1% annual interest compounded monthly. So what is N? I'm sorry? 12. Your account has $27,466.37 in it today. What letter is that? That's A. That is not what you started with. That's what you have now. Oops, it's supposed to say 27,000. It wants to know how much you started with. We're going to solve for P. Once again, money. So green. 27,466.37 equals an unknown principal. 1 plus 0.021 over 12 raised to the 12 times 24. So you know, 12 times 24 is 288. All right. Let's pretend for a moment that all of this stuff right here was equal to 5, okay? If it said 5p equals a number, how would you get p alone? You would divide, wouldn't you? This is a multiplication. So what we're going to end up doing here is we're going to divide both sides by whatever that number is. The reason why I told you this is for those of you that are using the battery operated calculator, so you could just use the exponent as 288. Let's figure out what this part of the equation is. Oof. Okay. Yeah, that decimal doesn't ever stop. It's ugly. It keeps going and going and going. Okay. If you're using the battery operated calculator, this question is slightly more difficult. It's going to require one more button press than it does on the calculator that I have underneath the camera, which I'll tell you about in just a moment. For now, what I'm going to do is I'm going to write it like this. About 1.65-ish. That's not very mathematical, is it? I did not round this number. What I did was I left it on my calculator screen because I'm going to let the calculator keep track of that long decimal for me. That's called floating your decimals. You're going to let the calculator float the decimals for you. I am not going to round that number. You don't do rounding early. You only do rounding at the end, never early. Okay? But we did say we were going to divide both sides by that number. So here's what I'm going to do. I'm going to tell my calculator I want it to divide 27,466.37 by that number. And this calculator has this awesome feature down here called answer. This is the last answer that it found. So I'm going to tell it 27,466.37 divided by second answer. And it is now going to do 27,466.37 divided by whatever that long decimal was. And then I can hit equals. You see, it kept track of all the decimals for me. I didn't have to bother rounding anything. Now this is money, so we'll round this to 2 decimals. And you'll notice that I engineered this question to end with a 0.00 when rounded to 2 decimals. $16,600. That is how much you started the account with. Can someone please loan me their battery-operated calculator so I can do it again using that calculator on video? Thank you, Donald, from the way back of the back. Nobody up front wanted to help me out. Oh, okay. Here's how we do it. So we're going to start here because we need this calculator to have the 1.65-ish thing on its screen. So 0.021 divided by 12 is, plus 1 is, raised to the 288 is. There it is. That's the 1.65-ish number. This calculator, I know it has a way of storing things in its memory, but it requires even more button clicks, and it involves this stow. And then later on, you have to do recall. But I really don't know how to use those functions of the calculator. I never bothered because this is just a hello, better calculator. So what I learned how to do was a way around it. I'm going to do this fraction upside down. I'm going to divide by 27,466.37. And I'm going to get something wacky because I know my fraction's upside down, right? See this button right here? It says 1 over x. That tells the calculator, now turn that fraction back, or turn that fraction upside down that you now have. Since the fraction I currently have is upside down, when I press this, it'll flip it right side up. And it'll give me the correct answer. So when you have to solve for principal with this calculator, I would suggest just doing the fraction upside down. That way it keeps track of this for you. And then at the end, just tell it, flip that back over for me. And it will. There you go. Thank you, Donald. Appreciate you. By the way, this calculator can do that also. It just doesn't say 1 over x. Do you guys see the quote-unquote 1 over x button anywhere? Written differently? Negative exponent. There it is right there, x to the negative 1. So this one would do it also. Let me prove a point. What's 1 divided by 2? As a decimal? It's 0.5, right? But if you flip that fraction upside down, what does it equal? 2. I'm just going to hit the x to the -1 button and hit enter. This calculator can do that too. But the answer feature is fantastic. But that's how I've gotten around using recall, and store on the TI-30XA. That's how I've gotten around it. And the last question is actually very related to this question. Here's what we know. After 24 years, this account had over $27,000. Unfortunately, you actually needed that account to have 32,000 in it after 24 years. So this account wasn't good enough. Its interest rate wasn't high enough. So let's assume that this was all the money you had to begin with. You had to start with $16,600. And you know you only have the 24 years. And you know you need it to have the 32,000 at the end. What would have been the minimum yearly interest rate needed in order for you to have that much money? And what we're going to do is we're going to round our decimal to 2%. No, our percent to 2 decimals. I switched the word decimal and percent there. That was weird. It says round to 2 decimals, but I want you to wait all the way until you've gotten your percentage, and then we'll cut it off at 2 decimals. Okay? All right. Let's fill in what we know. We know that P is 16,600. We know that A, the amount we needed, was 32,000. We don't know R, but we still know that N was 12 because there's 12 months in the year, and we still know that we were dealing with those same 24 years. And 12 times 24 is still 288. And our job is to get R alone. We need to isolate R. It's good old sad MEP. Just get it alone. That's all we have to do. What's our first step in trying to get R by itself here? Which is just sad MEP, guys. PEMDAS in reverse order. What are you going to do first? Nobody's saying anything. Is it because nobody knows? Divide. As your only options were division or cancel an exponent. So since we're doing PEMDAS in reverse order, we're clearly needing to divide. That is a good question. Why did you use your sniper? Is that what he asked you? We're playing video games instead of learning math? That's unfortunate. It's on YouTube now. All I have to do is say your name and it'll be on YouTube forever. All right. Of course, that would require me to know the names, but, whatever. Let's see, 32,000. Nobody even laughed when I said that. You guys are killing me. Once again, I have an ugly decimal. I want my calculator to float this for me. I don't want to round it. Don't round now. You round now, your answer at the end will be wrong. And that's because you will have rounded several times throughout the process. And when you rounded things, you end up with very, very large errors. Anyway, I'm going to write 1.93-ish. Now, we know it's not 1.93, but I'm not trying to write all that stuff. Clearly, R is trapped inside a set of parentheses that has an exponent, which means I need the exponent to go away. How do we typically cancel exponents? Radicals of some sort. So we could technically do the 288th root of both sides. But I'm going to be honest with you, using the root feature that is not a square root on these calculators is not the easiest thing in the world to do. On this one, it's not terrible. You just do second caret. But even then, I'm not really sure how it would handle it. Yeah, so what my calculator is trying to do is it is going to take the 1.93-ish root of something, which is wrong. That's not what I wanted, is it? So it's not the easiest thing in the world. You would have to know how the button works. And I'm going to be honest with you, I don't know how to do it on the battery operated one. So I would rather not use a radical. Instead, I would rather use something that we all know how to do on our scientific calculators. That's exponents. So instead of saying the 288th root, what exponent could I say? Have to remember, how do we convert radicals to exponents? 1 over 288. You raise both sides to the reciprocal power. Because remember, when you have a power to a power situation, you have to multiply those exponents. So if you multiply these two exponents, you get a 1. That's why radicals are actually fraction exponents. So we're raising both sides to the 1 over 288. Mr. M, why'd you use brackets instead of parentheses? Because I didn't want to see parentheses on parentheses. That's really the only reason why. It doesn't matter. Hey, there's that 1.93-ish. And I'm going to tell my calculator, raise that number to this fraction. I don't know how to use a fraction command on this calculator, so I just use parentheses and I say 1 divided by 288 and close them up. I know the battery operated one has a slightly easier fraction command if you felt like typing it that way, but I don't. I always use parentheses and type 1 divided by 288. And hit enter. Boom. Again, don't round anything. This is about 1.002-ish. Now what? Just trying to get R alone. Where do we go from here? Lots of people know. I mean, thank you. I'm glad you always talk to me, but lots of people know, right? Thank you. Subtract 1. I need more than one person to speak to me, guys. Subtract 1 from both sides. I don't need a calculator for that. That's going to get me 0.002-ish equals R over 12. And the very last thing I'm going to do is get rid of that division by multiplication on both sides. I'll multiply both sides by 12. And that's going to leave me with R equals the so minus 1 we said. This number, the 0.002-ish number, times 12. You see the calculator handled all the decimals for me. I get this is about 0.027, I don't know, 38. Mr. M, why'd you go to so many decimals? Because I wanted a percent. So times 100. Round that to 2 decimals. So you needed that account to have more than 2.73% annual interest rate. So if you had a 2.74, it would have done it. Yes, sir?
The battery operated one?
Yep.
It's easier.
What is easier?
It's 1 to the second, and then y to the x, and then you type that decimal in, like 288. Or type the exponent in.
Yeah.
Yeah.
That's not easier. It was the same.
Instead of doing 1 over 288. Like how you were saying. 1 over 288 is so 3,200. I was going to show you.
Yeah, well, I want it to be on video then.
Okay.
So 32,000 divided by 16,600.
Mm-hmm.
Okay.
And then you do second.
Oh, so it's doing this x root still.
Yeah.
So second that thing.
And 288.
So it's putting this inside the radical. Yeah.
Get that 1.002.
On mine, what I would have had to have done is know that it does the information backwards. And I would have had to have done this. I would have had to have said 288 second of the answer. But because they're different commands, I just prefer the 1/288. But yeah, cool. Thanks. It's good video. Good content. Like and subscribe. Merchandise in the link tree below. All that crap.